All right, so this is a titration calculation example. Now this is a pretty long problem, so you want to make sure you're following along and writing it as I'm doing it. Okay, so it might take some time here. But the purpose of a titration calculation is being able to figure out how much base of a solution needs before it changes color. Remember that video we saw where of a titration example occurring, we were waiting for the whole solution to turn pink. So, and this is the whole purpose we do titration calculations, is to determine the concentration of hydrogen ions and therefore the acidity of the solution. Remember we talked about acid rain, and we want to figure out how acidic lake water is and how potentially harmful that could be to the fish in the lake. So here's our example. 100 milliliter sample of aqueous sulfuric acid, H2SO4, is titrated with 2.0 molarity of sodium hydroxide. After adding 50 milliliters of sodium hydroxide, the indicator changes color at pH of 7. What was the starting concentration of H2SO4? So basically we're trying to figure out the starting acidity or concentration of our acid. So the first thing we want to do is to write out a chemical equation. Okay, so we're starting with sulfuric acid, so H2SO4, and that's aqueous, right? It's going to dissolve in the water. And this is plus sodium hydroxide, right? And we can see that in the problem. And this is going to produce sodium sulfate. Oh, and sodium hydroxide is aqueous as well. Sodium sulfate plus water. All right, so we do need to balance this real quick. And I'm going to kind of cheat a little bit. I have it written down, so it's actually just going to be 1, 2, 1, and 2. All right. So we have our balanced equation. Okay, that's kind of step 1. Step 2 is to find the total number of moles of NaOH, sodium hydroxide, that were used to neutralize our sulfuric acid. So moles of sodium hydroxide, this is going to equal our molarity, right, our capital M of NaOH, and we're going to times it by our volume, right, how much we put into it. All right, so that's our equation, and so if we look from our problem, we can see, let's see, our molarity is 2.0 molarity, so we can write that down. And that's going to be times, oh, and also we can remember molarity is the same thing as moles over liters. So that's actually going to be helpful for this to help eliminate the equations. And then we times it by 50 milliliters of sodium hydroxide. Now we're going to change that into liters. So we're going to bump that decimal place over 3 spots. It's going to be 0.050 liters. Okay, and that'll equal our moles. So our moles, we just take 2 times 0.05, and that's going to equal 0.10. All right, so we're going to use that number for the next step. All right, so since 2 moles, we now know basically every 2 moles of sodium hydroxide are needed to neutralize every 1 mole of sulfuric acid. We have to, it must be that hydrosulfuric acid must be half the number. Okay, so if we look at this, we're then trying to find the amount of moles of our acid, which is hydrosulfuric acid. So moles of sulfuric acid, this equals half the amount of moles of NaOH, which we just calculated. And so it's 1/2 times 0.10. If we do that, we'll get 0.05 moles of sulfuric acid. All right, so now we know how many moles of sulfuric acid there are, right? And then now we can convert it into our molarity. Okay, so we have one more step. So we have the moles, now we need to find molarity, right? The concentration of sulfuric acid. Right, and you remember molarity, this equals moles over liters. So the moles we just calculated, 0.05 moles. And then let's go back to our problem. And this is in a 100 milliliter sample. Okay, so we're gonna shake that and convert it into liters, which is 0.10 liters. And so 0.05 divided by 0.1, that's going to equal 0.5 molarity of sulfuric acid. And that is our answer. So I understand that can take a while, but really the purpose again is to find how concentrated, how much acid is in this solution, in this case of like rainwater. Okay, because then scientists can figure out if this is deadly and toxic to the wildlife in it. So the worksheet below is just kind of go over some of these things about being able to navigate between moles and molarity, which is something we've done in class towards the beginning of the semester, and basically understanding what we're trying to do with titrations. If you have any questions, let me know, and we'll talk to you guys later.